Hello class, so today we're going to be doing things a little bit differently. First, I want you to be taking notes of this video, and then I also want you to be writing down all of the work for each example that we go through. What I'll be doing is right now I'll just pause the video and let you get your notebooks out, so go ahead and do that. And then throughout the video I'll be resetting the screen so you might see it jump, and that'll be just so that I can erase the board and write an example without wasting too much time. Okay, so without further ado, let's jump into it. This section is 2.2, the addition property of equality, and this can be found on page, I'll just write it down, page 92 of your textbook. So we'll start by just talking about basically what concepts are included in the section and what definitions that come up. So the first definition is a linear equation. Okay, a linear equation is an equation that we can draw on a graph. And it takes the form ax plus b equals c. So this x is going to be our variable, which is something we've talked about in the past, right? And a, b, and c are just real numbers. So a, b, and c are included in the set of real numbers, okay? And they're just placeholders. Now, what are we going to do with these equations? Well, a linear equation has a certain solution, x, for each real number a, b, and c, right? So there is a specific x that'll make this statement true. And our second definition is equivalent equations. So equivalent equations are equations of the linear form that give you the same solution. So equivalent equations are equations that have the same solution. So equations that have the same solution. And if you remember from chapter 1, we talked about the definition of solution, right? So the solution is the value for x that makes an equation true. So if we had something like 4 plus x equals 0, there's one value for x that makes this true, and we call that a solution. In this specific case, we have x is equal to -4 because 4 minus 4 is equal to 0. Okay, and this is the type of stuff that we're going to be doing in this section. We're going to be trying to solve for x. But first, one more definition, and then we'll get on to examples. Okay, so this is the last definition that we'll go over, and this is the crux of this lesson. So it's the addition property of equality. For this definition, again, we're going to assume that a, b, and c are in the real numbers. So this is our assumption, and if this is the case, then we can say that a equal to b and a plus c equals b plus c are equivalent solutions, or equivalent equations, sorry. So these are equivalent equations. Now, why is this a big deal? Why is this the center point of this lesson? Well, going back to our example of 4 plus x equal to 0. So since we have this addition property of equality, right? Look at 4 plus x as a and 0 as b. We can add then some real number c to both sides of the equation, and we'll get an equivalent equation. And again, equivalent equations have the same solution. So if we add, let's just say -c or -4 to this equation on both sides, we get 4 plus x minus 4 equals 0 minus 4. And again, I'm just adding 4 to both sides. Right? Now, if you evaluate this expression right here, let's just bring it over to the right-hand side. 4 minus 4 is just 0, so on the left-hand side we have x. But on the right-hand side, 0 minus 4 is minus 4. And you see we get the same solution that we got before. X is equal to minus 4, right? Now, an important thing to note is that this would not change if we had x on the right-hand side. So if we had started with something like 0 equals 4 plus x, we would still wind up with the same solution. It would just be with the x on the right-hand side and the negative 4 on the left-hand side. There is no difference between these two equations. These are the same exact equations. So it does not matter whether the x is on the left or the x is on the right. Okay, now that we have the concepts and the definitions down, let's look into some examples. Okay, so here we have two examples, and this is just a reminder. What I want you guys to be doing is writing down these examples in your notes, and each time I show you an example, I would like for you to pause the video and try to solve the example before I go into details. So if you could just pause the video, try to solve it yourself, and then I'll go into the solution. Okay. Hopefully you've paused the video by now and we can talk about the solution. So here we have another simple example like the ones that I've showed previously. X minus 7 equals 10. So in this case, what we're going to wind up doing is we're going to be adding a 7 to each side. Why? Because the key is to isolate x. So when we add 7 to both of these sides, we'll have x minus 7 plus 7 equals 10 plus 7. And here what we've done is we've canceled everything out except for x. So now on the left-hand side of our equation, we just have x, and 7 plus 10 is 17. And there we have our solution, x equals 17. Okay. Now going over to example 2. In the first case, we added a positive 7 to both sides. But in this case, since we have a positive number on the left-hand side, we're going to subtract. So we're going to take a negative 0.6 to both sides of the equation. Okay. And this is going to give us y plus 0.6 minus 0.6 equals to negative 1.0 minus 0.6. Sorry, I'm running out of room. Okay. Again, we've created a 0 here by adding that negative 0.6. So we just have y on the left-hand side, and on the right-hand side, we have negative 1.6. Okay. Now, in our definition of the addition property from the, I was about to say previous slide, but from earlier, we talked about adding a real number to both sides. In example 2, we have simply added a negative number, right? So you can, in a sense, subtract from both sides as well, right? A negative number. Because subtraction can always be phrased as addition of a negative number. So you can either add or subtract. And now we'll go on to some more examples. Okay, here we have our third example. And again, as a reminder, pause the video, try to solve it yourself, and then I'll go into the answer. So, in this example, we have two t's, right? So we have a t on the left side and a t on the right side. How do we deal with this? Well, if possible, we always want to have, in this example, we would have t equals some number, right? So we want to have a singular variable on one side of the equation. So I would advise when faced with a problem like this to always leave the bigger variable, in this case it would be 6t, leave it where it is and move the smaller one, which is going to be the 5t. And I would advise doing this first and not trying to do all of the steps at once. So in this example, we're going to subtract a minus, or add a minus 5t to both sides of the equation. We're going to leave the 5 and 2 where it is. So that way we're left with minus 5 plus 5t minus 5t equals 2, 6t minus 5t plus 2. And here we have, I'll often do this notation to where I dash out certain terms, and that just means those terms cancel out, okay? This 6t minus 5t becomes just t, because 6 minus 5 is 1. And then our next step is going to be adding a negative 2 to both sides of the equation, and we're left with minus 5 minus 2 is equal to t. Doing our last step, we get minus 7 is equal to t. Now here we have an example of an equation where the variable is on the right side instead of the left side. Like I said, this is totally fine. There's no difference between putting t on the left or t on the right. You'll get the same solution. So now let's go on to our next example. Okay, so here we have our final example. We have 6 times 2a minus 1 minus 11a plus 6 equals 7. Again, I want you to pause the video and try to solve this yourselves. Okay, so we want to always keep in mind order of operations. So in this, we are going to do the parentheses first. So we're going to distribute the 6 to both terms. And we're also going to distribute this negative to both terms inside the parentheses. So when we do that, we get 12a minus 6 minus 11a minus 6. That's going to be equal to 7. So simplifying this a little bit further, we're going to get 12a minus 11a is going to be just a singular a, and minus 6 is minus 12. That's going to be equal to 7. And our final step is going to be adding 12 on both sides of the equation, which will give us a minus 12 plus 12 equals to 7 plus 12. These terms over here cancel out, and we are left with our solution. A is equal to 19. Okay, so this was our final example with written equations already given to us. One thing that I want to go over is word problems and how to use equations to solve word problems. And here we have our last example. It reads, Brett is 4 inches shorter than Dane. If Dane is 2 inches tall, express Brett's height as an algebraic expression in t. So one thing I do want to highlight is in t is basically just saying this is something that might be phrased as in terms of, right? In terms of. And this just means that the algebraic expression or the variable you're looking for, right, will be on one side, and this t, whatever you're putting it in terms of, will be on the opposite side of that. So in this example, we can just make up a variable for Brett's height. Since his name starts with a B, we can just call it B, right? Now, Brett is 4 inches shorter than Dane. So that means that we're going to be taking away 4 inches from Dane's height. Dane's height is T. Dane is T inches tall. So we say that B, Brett's height, is going to be equal to T minus 4. And this is going to be an algebraic expression. This is going to be an algebraic expression of Brett's height in terms of T. So this is it for this video. And once you finish up your notes, go ahead and submit them on Schoology. I hope this was helpful. I hope you learned. And I'll see you next time.